So let's go up and let's go back and do number 1. So here's the reason I saved this one for necessarily not the very beginning, because of the complexity of this problem, and you'll see what I mean by the complexity of it. All right, so we're going to start out with 1A. So it says, please convert these measurements into moles. Okay, so we're going into moles from these things. So it says 9.03 times 10 to the 23rd carbon atoms. Now, before we go any further, why does that say atoms and not molecules? It's just one single thing. Okay, so here's the question. So based on this little flow chart, can I go from atoms to moles in one step? Yes. Okay, we can. We can do it in one step. Are y'all okay back there? Okay. All right. So if atoms is on top, where do we put it to cancel it? On the bottom. So I've got atoms on the bottom, and I'm going to go to moles on top. Now, here's my lack of fear. I think this is going to be pretty simple. These two numbers will always be the same no matter what problem we have. What do you always put beside moles? 1. What do you always put beside atoms? Avogadro's number? Yeah, Avogadro. Here's the part that scares me. Your ability to functionally and correctly put this in your calculator. I don't worry about you writing it down. I worry about you being able to plug it in and actually get the correct answer in your calculator. So if you have yours today, please get it out. If you don't have one, please come up here and get one out of this box. You need to practice this. Okay? So from here on out, you need to bring your calculator every single day. Okay? Every single day. So I'm going to show you how to do this the first time together. And then after that, I want to make sure that you can kind of do this all on your own. Y'all, Mason, what's so funny, dude? Well, how about putting the phone up, please? Okay. All right. So we've got 9.03 times 10 to the 23rd. Now, am I multiplying or dividing those numbers? Dividing, very good. Make sure that you know why we're dividing these numbers, because one's on top and one's on bottom. So 2nd to the 23rd, and then I'm going to hit equal. Sir, okay? Sure, if you want to. If you want to, that's fine. But it's, I mean, essentially you're adding a step that you don't even need. It's the exact. Yeah, absolutely. If that will make it easier for you, absolutely. Every single one of them can be. Yeah. The reason I think that this problem is more challenging than the rest of them is because the fact that we've got two numbers that you have to do the scientific notation for. And if you've got a calculators like Vi, I'm trying to see. Yeah, hold that up a little higher. If you've got one like that and Chloe's, it's going to be a pain in your rear. Those calculators are very complicated. If you have one like this, it's a lot easier than what you're using. Okay? So, again, I don't worry about you writing it down. I worry about you being able to plug it in. Okay? So if you get 1.5 and you can reproduce those results consistently, then I'm not worried about you. But if you plug it in and can't get that number, then I need to help you guys out. Is there anyone that can't get this number? Okay. Now, so as long as you got that 1.5, that's fine. But here's something else I want to make a point of emphasis on. Last week I taught you that there are 3 things you now have to concern yourself with. One of them is significant figures. The second thing is the unit. And what was the third thing? Whatever substance it is. And in this case, what's the substance we're dealing with? Carbon. Now, this problem is actually a problem. And I mean, I know it sounds weird, but this particular question causes us an error. How many significant figures are in the given? But your calculator only shows you 2. How do you make it 3? Add a 0. Very good. So it's 1.50 moles of carbon. So 1.50 moles of carbon. Always. Always, always, always. Okay? So here's what I want you guys to do. I want to see if you can do 1D all by yourself. So set it up and go from 2.44 times 10 to the 23rd water molecules to how many moles that is. And again, it's all about setting it up, making sure that your units cancel, making sure that you have the right number in the right place, and then can you physically get it in your calculator correctly and get the right answer. So as you work it out, I'm going to put the answer up here on the board. Instead of why can you not write atoms here? Because it's water, and water is a molecule. That's why you have to write molecules. All right, so this should be your setup. So you have Avogadro's number of molecules on bottom and 1 mole on top. And what did I do to these two numbers? Divide, and over here the calculator should have been the answer you got in your calculator. Okay. I did D. Would B go to 1? Sorry. Yes, B would go to 1 because you're dividing the same number. Yes. Yes, B would be 1. That's why I didn't want y'all to do B. Alright, so that should have been your answer. So what would we round this answer to? Very good, 0.405. Let me scroll it down, make sure it's in the right place. Okay, and so it is 0.405 moles of H2O. Does that make sense? Okay. Again, I don't fear you guys plugging in the right numbers. I fear you plugging it into the calculator. Don't let the calculator be the reason you don't get the answer right. Okay, that's my biggest fear, is that you guys don't do this right in the calculator. Everybody good on this? Okay. All right, so let's scroll down and let's look at 4, number 4. Did we do any of these? No? All right, good deal. So let's look at 4A. So this time we want to convert moles into grams. So my first question is, can I do that in one step? Can you go from moles to grams in one step? Yes, you can go to moles to grams in one step. So let's look at this. 4A. All right. If moles is on top, where does it go? On the bottom. And again, I want to ask this question, why am I putting it on the bottom mathematically? Very good. So when I want to get rid of it, so I can do that. And now it can go to grams. Okay. The simple one, anytime you see mole, no matter where it is or how many there are, what do you put beside it? Put a 1. And then grams is going to be the aggravating. Okay. What do you need in order to get the grams? Periodic table. Now, is this going to be an easy one or difficult? It's really easy. Because is there one box with just the letter K in? Fantastic. That's making this a lot easier. I'll go ahead and tell you, it is 39 point. Now, how many decimal places do you round masses to? 2 decimal places. So it's 39.10. Okay? Compounds? I will give you the element or the compound, and you've got to figure out the mass. Always round it to 2 decimal places. Yeah, use them, whatever the mass is on here, always round it to 2 decimal places. Well, I mean, they're all going to be very similar. Yeah, this right here is very similar to that. It may be 1 or 2 decimal points on. No, I know what's on this. Yeah, I'm going to go off this. Now, in your calculator, this is much easier. You've done numbers like this your entire life in a calculator. What are you going to do, though, mathematically to these two numbers? Multiply. So go ahead and multiply this out. All right, that is the mass of potassium on the periodic table. So if you look up there on that wall, by letter K, it'll say 39.10. Does that make sense? Okay. Yep. All right, so 3.5 times 39.1. And then that's the answer right there that pops up. Okay. Now, how many significant figures out of that number do we need? 3. So what are you going to round that to? 137. Very good. So now, it's specifically 137 what? Grams of potassium. Very good. So 137 grams of potassium. Any questions on that one? 137 grams of potassium. Yes, 3 point. Always go with the given in the problem. Put it up, please. I'll put it in your name. So let's go down and do 4C. So let's go down. So 4C. All right. So we've got 62.5 moles of carbon dioxide. So if moles is on top, where does it go? Goes on bottom. Can I go from moles to grams in one step? Yep. Okay. Again, no matter where it is or how many moles you see, what do you always put beside moles in the parentheses? 1. And where are you going to get grams from? Periodic table. Now, here's the problem. Is there one box with CO2 in it? No. So we got to do something called the calculation of the molar mass. Now, let's see if we can do this one in our head. I promise it's easy. All right. Does anyone know how much oxygen is? 16. Okay. How many oxygens are there? 2. All right, what is 16 times 2? 32, right? All right, so that's for the oxygens. Now we need to add carbon to it. Carbon is 12.01. All right, well, what's 32 plus 12.01? Try again. 44.01. Now, I know what some of you are going to say. Wait a minute. How did you get that number? Give me a second. Let me show you. So again, what we do is we say, what is our compound? Okay. You write down each element. You write down how many are present. So how many carbons are there? There's 1 carbon and 2 oxygens. Then you multiply it by its mass on the periodic table. And this is where these numbers are coming from. 12.01 is on the periodic table. And then we already know that oxygen is 16. So what you would do is you would just do that math. And this math would come out to be 44.01. Okay? It's 32 plus 12.01. Okay? Now, side question. There's a unit for molar mass. What is it? Say it again, Jason. Very, very good. We had this discussion on Friday. When I asked you guys what miles per hour meant, you told me it's how many miles you go in how many hours? 1 hour. So it's how many miles you travel in 1 hour. So when you say gram per mole, it's how many grams you have in what? 1 mole. So if I handed you this mouse and I said this mouse is 1 mole of carbon dioxide, then how much would this mouse weigh? I just said it's 1 mole. How much would it weigh? 44 grams. If this mouse is 1 mole, right, per mole, if it's 1 mole of carbon dioxide, then it has to weigh how much? 44 grams. So let's think about this logically for just a second. If 1 mole is 44 grams, how many moles did you start with according to the problem? 62 and a half. So if 1 is 44, bingo, which is exactly what we're doing. So it has to be more than 44. In fact, it's got to be 62 and a half times more. So logically, this should make sense. Okay? Logically, it should make sense. So let's plug this in and see what we get. So we've got 62.5, let me get this right, times 44.01, and there's your answer. Okay? Now here's the deal. We still only need 3 significant figures. So, this is where I've noticed students kind of mess this part up. You get the right answer in the calculator, but you get it wrong on the test. Because people say that the answer is 275. If I was going to give you $2,750 versus $275, would you take it? The more money, the better, right? So anytime you have a value left of the decimal, what I mean by that is it's in the ones, tens, hundreds, thousands, 10,000s place, and you don't need the number, Do you drop it or turn it to a 0? Turn it to a 0. So do we keep that last 0? Yes, because we need 3 significant figures, and that 0 is to the left. So it's going to be 2,750 grams of carbon dioxide. Now, I'm going to ask this question. Can that be written in a different format? Someone tell me if this is right or wrong. Is that the exact same thing? Remember. So we've got King Henry died at a bar drinking chocolate milk. So if I've got 2,750, where's that decimal place currently? Okay? And then how do I get to kilo? 1, 2, 3. So it's going to go 1, 2, 3, which is equal to 2.75 kilograms. So either way is appropriate. Okay? Either way is appropriate. All right. Now, what I want you guys to do is I want you all to do, and this is going to be the one that's going to challenge you to make sure you know what you're doing. Number 4, letter D. 7.9 times 10 to the 9th moles of water. And I want to know how many grams that is. Now, 2 things. Number 1, notice that the given's in scientific notation. Number 2, notice that there's a compound for the formula. You should know the mass of water. That's the only one I've asked you guys to memorize. If you don't know what the mass of water is, figure it out. Calculate it. In fact, you're more accurate. Okay, yeah. So let's look at this. So the first thing we need to do is, where do we put moles to get rid of it? On the bottom. Okay. We can go from moles to grams in one step. We know that moles is always 1. The mass of water is 18.02. So that's going to be the number we got to deal with. Whose music's so loud? Guys, y'all need to take headphones completely out. I don't want to see them. Okay. Completely away. Thank you. All right, so then we bring this over here. And let's cut it on. Let's clear it out. So we've got 7.9 to the 9th power times 18.02. And that's going to be your answer. Okay? So what do we round this answer to? Here's what scares me. That's what some of you are going to write. That's what I wrote. Why is that wrong? It's very easy to miss that back end part right there. And again, that's you knowing your calculator. I can't teach you this. I can only show you repetitively, and you catch on that, hey, I need to look at the very end of my calculation to make sure that what I have is accurate. Because if you wrote what I currently have written in blue, that's wrong. If I was going to hand you $1.40 or 1.4 times 10 to the 11th, what would you rather have? The bigger number, right? Okay, think about it. The 12th is the billionth power. I'm handing you $140 million, according to that. Pay up, right? But if you leave it off, that's a significant difference. Significant difference. Okay, so make sure that you catch that at the end. All right, if you guys will flip over, let's look at the next set, 5A. So, problem number 5, what's wrong? That's what we're fixing to do. So, problem 5 says, please convert these measurements into atoms/molecules. Okay, and then problem A says 17.4 grams of K. What is K? Potassium. Is potassium an atom or a molecule? and atoms. So for the first problem, we're going from grams to atoms. So this is the major question. So going back to our flow chart, according to this, can I go from grams to atoms in one step? Who's in the middle? Moles. You can't go anywhere without going through moles first. And this is a common theme that you're going to hear the rest of this year, is the mole is going to be the most important aspect of all of this. So let's set it up and let's see what we know what to do. So we've got grams here. So let's just keep it simple. I know I have to get rid of grams, right? Where do I put it to get rid of it? On the bottom. We already know that. You may not know anything else, but you know that is true. You just told me that I cannot go to atoms in one step. Who do you have to go through first? So we already know that we can go from grams to moles. We've been doing this step the entire time. But here's the all-important question thus far. Why can I not stop, write equals, plug everything in, and give you the right answer? What was the question asking for? I got to get to atoms. Well, I'm not there yet. I got to go one more step. So set up another step. Okay. We already know that mathematically my grams have canceled. Well, I've got moles. If I want to get rid of it, where does it have to go? It's got to go to the bottom. So I now know, mathematically, moles have now canceled. Well, here's where people kind of get stuck. Well, what goes on top? Can you go from moles to atoms? Yes, you can. So nothing is different as far as the concept. We just have to add a step to it. And everything stays the same from here on out. No matter how many you have or where they are, anytime you see moles, what do you put beside it? They both get ones. Doesn't matter. Anytime, any amount, or wherever they are, what do you always put beside atoms? Avogadro's number. Doesn't matter where it is. Put it there. And no matter where it is, or how many of them you see, where do you always get grams from? The periodic table. Now, what's the good news about this one? It's just one thing, so we can just look up there and find out what it is. And the mass of potassium is 39.01. So, yeah, 0.1. It's 0.1. That's correct. Yes. So here's the deal. Now, the only difference in this problem is you've got to multiply and divide. So my question to you is, what are you going to multiply times the 17.4? Avogadro's number. Anything that's ever on top, what do you do with it? Multiply. And anything that's ever on the bottom, what do you do? Divide. You can do one of two things. I don't care. You can go ahead and multiply everything on the top and then come back and divide by the bottom. Or you can take it one set of parentheses at a time. So you can do 17.4, since it's on the bottom, divide by 39.1, and it equals, and hit equals. And then go to the next step. Well, since Avogadro's number is on top, what do? Multiply, and then hit equals. And if there was any additional steps, you would just continue on doing what you want to do. But if you, however you want to do it, is perfectly fine. As long as you multiply when it's on top and you divide by when it's on bottom, you should get the right answer. So what I want you guys to do, go ahead and plug it in. And as you're plugging it in, I'm going to put it up here and see if you get the right answer. You have a question or an answer? Okay, go ahead. Absolutely. Matter of fact, let me show you. Okay, so I'm going to do parentheses 17.4 times 6.02 second 23, 23, close parentheses, divided by 39.1, and there's your answer. And why do you have to put in parentheses? Order of operations. If you do it in the incorrect order, it may throw your answer off because of order of operations. And do you agree that these two things are on top? Let's keep them together. If you didn't use parentheses, that's fine. I have a habit of it because I want to make sure that I'm making those numbers multiply together. That's fine. I mean, you can do it either way. You can divide and then multiply. That'll work. Yep. Whatever you feel comfortable with doing in your calculator is going to be the deal. So is that what everyone got? Again, here's my fear. That this is what some of you write. I need 3 sig figs of 2.68 atoms of potassium. Here, that's my fear. That you write there 2 atoms of potassium in 17.4 grams. How small are atoms? Do you think there's only going to be 2.68 atoms? That doesn't make sense at all. Okay? That makes absolutely no sense. Again, is it easy to miss this part right here? Very easy. So make sure you pay attention to that. So it's 2.68 times 10 to the 23rd atoms of potassium. Yes, sir. Come up here. All right, so here's what I want you guys to do. See if you can do D. That was what I was going to do next either way. D. All right, so before I show you the answer, is this what everyone has the correct setup? You divide by 18.02 grams because that's the mass of 1 mole of water. And then in 1 mole, there's Avogadro's numbers worth of molecules. Now, why is it molecules and not atoms? Because water's a molecule, not an atom. So, what I've done up here in the calculator is I've multiplied across the top, and I hit equals, and now I'm divided by the mass, and this right here should be your final answer. Okay? 1.30 times 10 to the 27th. Again, if you're not getting this, we need to make sure we fix this as a calculator issue. So 1.30 times 10 to the 27th joules water. Okay? It'll be, I can't remember, I'll have to look it up, but each math problem is worth so many points. It'll be just like the other one where you'll have to draw and write stuff on the back. It'll be, I'll take those two tests and combine them.